All right. In this problem, we'll go over the graph from class, and let's take a look here. So we're going to do question 1. When did the object change direction? Well, if we look at this, a change in direction is a change in velocity when it changes sign. So if we look at the very beginning, it doesn't tell us, but our assumption is we would have to be told this, but the initial velocity equals 0 meters per second. Right. So we're looking for when it changes to negative. Well, if we look at this, when the time is greater than 0 seconds, but the time is less than 2 seconds, so that would be from here to here, what's happening? Well, in this section, from 1 to 2 seconds, I have a positive force, right? And if I have a positive force, then that is going to be a positive impulse. Right? We also know impulse is F times T equals M delta V. So if this side is positive, this is a scalar, and this is a scalar, so that doesn't matter. That means my change in velocity is positive. If I started at 0, I will end up at a positive velocity. So in this segment, I know I have a positive velocity. Also, if I look at it, it says I have a positive velocity as soon as I start after 0 seconds. And then in this segment, right, if you notice right here, this always has a positive force. So in sections 1 to 2, it's always speeding up, right, because I have a positive velocity, positive force. After that, what's happening down here? Well, from in section B, right, this one has a positive velocity, but a negative force. So I'm moving to the right, but I'm being pushed to the left. So that would be slowing down in segment B. If we look at 4 seconds, we know that the impulse equals the area. And this is going to be the F net average. Why is it an average? Well, hopefully you can clearly see on this side that the force is always changing. If the force is changing, then it is going to be an average. Now, if we keep going, at section B, we said that's a positive area. Sorry, at section A, we said it's a positive area. At section B, it is a negative area. Now, if I wanted to compare these, I could see that if I were to calculate the area of this shape, right, and I were to calculate the area of this shape, those are both the exact same. One is positive, one is negative. So if I added them up at 4 seconds, the area equals 0, which is the impulse. So the impulse equals 0, which equals M delta V. If this side is 0, this entire side to the right of the equal sign also has to be 0. But again, we see that mass is a scalar. Well, that doesn't even matter. Mass is a value. That's not going to change. But we can see if one side is 0, the other side has to be 0. So this means our delta V also has to equal 0 at that point. We said that you started off at an initial velocity of 0. So if my change in velocity of 0, the speed at 4 seconds is 0. Now, what happens in this tiny bit of segment? As soon as I go past this, the area here is going to be negative. So if I have the area, which is impulse, is a negative number, then I can set this equal to mass times change in velocity. This is where mass is a scalar, so it doesn't do anything with direction. So if I have a negative on the left side of my equation, the velocity also has to equal a negative number. I guess not the whole thing, just that. Right? Once the velocity is now negative, that means I have a negative velocity, so that is where it changed directions at 4 seconds. Now in question number 2, it wants to know what is the maximum speed. We just learned that the speed at 4 seconds right here is 0. So this is 4 seconds. After that, I have a negative velocity. I also have negative forces all the way to D. So in that scenario, what am I going to do? I'm going to be speeding up if I have a negative velocity and a negative force. I'm moving to the left, and I have a force pushing or pulling to the left. So you're going to speed up. Into section E, you had a negative velocity all the way here, getting more and more and more negative all the way to 7 seconds. After that, towards 8 seconds, you now have a negative velocity and a positive force. And this area, right here in this segment, ends up canceling out this area. So you would slow down, but you would still be at a negative velocity because I slowed down by this amount. You can calculate it, but either way, I look at section E, it's slowing down. So I'm no longer getting faster, so it has to be at 7 seconds here. On to question C, or 3, excuse me. What was the velocity at 5 seconds? One more time, the velocity at 4 seconds is 0. Right? Then I have to look at 5 seconds. So at 5 seconds, it's going to be area again. The area of this is force times time, or length times width. So the length is 1 second. Right? The, where are we at? The height of this is negative 6 seconds. So if I finish this, my impulse or area is, whoops, that's not 6 seconds, 6 newtons, is negative 6 newtons times seconds, which is the impulse. But now if we were to finish this problem, we need velocity. So this is impulse, so I can see that J net equals negative 6 newtons times seconds. But if I want to find the velocity, that is equal to m delta v. Right? We don't have the mass, so let's just pick 1 kilogram for this problem, but you need the mass. Make it a little bit easier, so negative 6 newtons times seconds equals 1 kilogram times the change in velocity. The initial velocity was 0. So when I do this math, I'm going to get a change in velocity equals negative 6. Right? I know the unit is meters per second, so the change in velocity, or the v final, excuse me, if the initial was 0, is v final equals negative 6 meters per second. That should also make sense because we said after 4 seconds I have a negative velocity, and I have a negative velocity here. Alright, the next one. What was the force average over the entire time? Well, it has to be with our equation. Force net average times T. Then over the whole time, well, what do I know that force average equals? I also know that's impulse, which equals the area in this problem. So we said this area here is canceled out by this area here. Those are the same shapes. Then we have this area here, which is canceled out by this area. So the area total for all 8 seconds is just this yellow section. Everything else is canceling out. So I have to find the area of this yellow segment. So if I were to go back here, I could look at this, and the base of this is 2 seconds. So right here is 2 seconds. The height is negative 6 seconds, or negative 6 newtons. Sorry about that. 2 times negative 6 is negative 12 for area. So this is negative 12 newtons times seconds equals the force average. So that's what I'm looking for. And then multiplying by the time. So I'm looking over all 8 seconds. So negative 12 divided by 8. And those are both seconds. That's 8 seconds. Seconds cancel. So I'm left with newtons. So I'm happy with that. 12 divided by 8. That is 3.5. or negative 1.5 for our force average. Number 5, I'm looking for a positive acceleration. So we know we're really only looking at one force. So if I'm only looking at one force, then this is just let's call it a force applied equals MA. This equals MA. So we want to find a positive acceleration. Right? That's a vector, so it has to have a sign. So if the A is positive, the force has to be positive. We have to get over, if the line's going down, that's a negative thing. Okay, we're reading, if it asks for force, you just read the y-axis. So anything above this will have a positive force, and then a positive acceleration. Right? This one, the line's in the same direction, but we're ignoring that. We're just looking over here. This has a negative force, so a negative acceleration. All of these sections, we don't care if it's going up or down, all of these sections, again, have negative forces, so negative accelerations. The very last one, back up to positive forces, so that is a positive acceleration. So I can see it is section A and section E have positive accelerations. Number 6 asks us for velocity. And we saw velocity comes from impulse equals m delta v. So this is also when the area is positive. Right? So in the first section, right, I have a net amount of positive area. That's only positive area. So that has to be a positive velocity because I started from 0. Sorry, which section? That's A. Okay. Also, if we looked at this one, the next one, all the way to here, okay, then this area cancels out, so my net area from A and B is 0. Did it ever go into the negative? It did not. If it never goes in the negative, that also means B has to have a negative velocity. Okay. After that, we've done this multiple times. This all is a negative area, so a negative velocity. The top section here, right, that cancels away some of this, but what is my net area? Still negative, and that was in our, which section we were looking at? That was in this section right here. So going back, that one is going to give me always a negative area, so I guess it's just A and B in this problem. Our last question asks, when is it a constant acceleration? Well, what causes acceleration? That is your force applied equals ma. So if I want this side to be constant, then this side also has to be constant. Back to these sections. I can look, and here, in the very first segment, that's changing forces, so it's not that one. Section B, also changing forces. Section C, right here, the force is always 6. So that is a constant force. So then that will give me a constant acceleration. And this will end up giving me only section C.